Hello friends, in this session we will be solving some numericals on induced voltage. Let's begin. Numericals on induced voltage, in the sense we need to find out induced voltage, right, for the problems. Before that, let me write some important formulas for you all so that you will have a list. Let us have one list of formulas. So now, first formula, if you see, or rather we are interested in only induced voltage, right? So let me write EPH, EMF per phase. RMS value is going to be, we have just now seen, it is going to be root 2 pi f phi NSE kpkd, right? Root 2 pi f phi NSE kpkd. This is what is formula. In which, if you see, this F stands for, in this one, in formula, F stands for frequency, which is in hertz, right? Then second is what? Phi, average flux per pole. Average flux per pole in Webers, Webers or milliwebers. Then we have NSE. NSE is going to be number of series turns. Right? Then what we have is Kp. What is Kp, sir? Kp is pitch factor. Pitch factor means cos epsilon by 2. Right? Pitch factor is given by cos epsilon by 2, wherein epsilon is nothing but short pitching angle. Epsilon is going to be short pitching angle. Then if you think of Kd, distribution factor. It is equal to what, sir? This Kd, which is there, sine q gamma by 2 upon q sin gamma by 2. Right? Now, wherein if you see here, this q which is there is what, sir? Slots per pole per phase. Right? And this gamma is what? Gamma, slot angle. Gamma is going to be slot angle. Now see here, very simple. This particular Kd, if you see, if this information is available, information of Q and gamma, then it can be easily found out. But I have told you that Kd they can also ask as, if for example in exam you have phase spread given, then what do you do there? There you have formula. See, we know that. First of all, let me define phase spread. If you think of phase spread, phase spread. How much is phase spread? Phase spread means, see here, phase spread is going to be Q gamma. We have seen that, in the sense slots per pole per phase, that is Q, multiplied by slot angle gamma. So that is going to be phase spread given by sigma, which is going to be Q gamma. Right? Now see here, if I think of Kd, Kd again, same Kd for this one is going to be how much, sir? Just replace Q gamma by sigma. So it is going to be sine. Replace, in place of Q gamma, you get sigma by 2. And we have seen that If my gamma is in radians and it is very very small, then this particular sine gamma by 2 can be written as gamma by 2 only, which means I will have q gamma by 2. Q gamma by 2 if I have, it is going to be q gamma. Q gamma is sigma upon 2. That's it. Very simple. This is nothing but KD. Now see here. This formula is used if gamma is in degrees, or it can also be in radians. No problem. But while using this formula, sigma which is there, that has to be compulsorily radians. Sigma has to be compulsorily radians. Why? Because this one came because we have assumed that it is going to be radians. Anyways, forget about it. This is the formula for you. That's it. Now next, Kp and Kd is done. NSE we have to do. Frequency F is done. Yes. Flux phi is going to average flux per pole. That will be given. Now see here, how to find NSE. If you think of stator, let me have this as stator. For example, I have conductor A here and I have conductor A dash here. Right? Why opposite? Because let me consider two pole. NNS, no problem. Right? Let me consider two poles. Now, these two can be shown as this one. These two can be shown as A and A dash. So, I can show this in the form of a coil this way, or you can say turn. Right? This is going to be it. So now you please tell me, how much is the number of turns? Number of turns, if you see, right? Number of turns, if you see, it is going to be, see here, when you have two conductors, you get one turn. When you have two conductors A and A dash, you get one turn, which means number of turns, or we can say that rather than number of turns, I can say that one turn is equal to two conductors, right? One turn meaning that two conductors. So how much will be n number of turns? N number of turns will be nothing but 2 times total conductors. 2 into total conductors. So number of turns, if you see, is going to be 2 times total conductors. Now see here, since we are interested in EMF of one single phase, right? One single phase EPH. So this total conductor should be also per phase. So that you get what? Number of turns per phase. Very important. Anyway, see here, when we are talking about short pitching angle, now do you agree that here the angle is going to be 180 degrees? Electrical also, mechanical also, but our thing is electrical. We are electrical engineers, so this is 180 degrees. Now see here, when you have this electrically 180 degrees, let me consider, rather than placing A and A dash like this, if I somehow place A dash here, for example here, rather than placing here, if I place A dash here, then what is going to happen? I will have A dash here somewhere, and this is going to be like this, right? Now see here, this complete thing is called as, this one is called, angle is called as coil span, and we know that this angle is called as epsilon. Short pitching angle means by what angle you have done short pitching, and for what span, for what angle my coil is present, it is going to be shown by coil span. So if I want to write the formula for coil span, what do I write? Coil span is going to be, how much it is going to be? 180 degrees minus short pitching angle. So it is going to be total 180 degrees minus, what is that? Epsilon, short pitching angle, right? This is for coil spin. Now, what else is left? Q and gamma. So Q, what is Q, sir? Q is going to be slots per pole per phase. That's it. That is the formula. Slots per pole per phase. Whereas if you think of, this is Q, right? So this was Q. Now, what is angle gamma? Gamma is going to be what? Gamma is going to be slot angle. Slot angle in the sense, angle between two slots, two adjacent slots. So now you please tell me, total electrical degrees. Total electrical degrees is 180 degrees, right? Total electrical degrees is 180 degrees into P. 180 into P, right? Total electrical degrees is going to be 180 into P. Already we have seen. So, divide by number of poles, number of slots, number of slots. See here, this is slot angle. So, how much is the total electrical degrees? P into 180 divided by number of slots will give me one slot. So, this is going to be slot angle. Slot angle is what? P into 180 upon P into 180 upon number of slots S. Now, if you think of here, harmonic, see here, what will be distribution factor? See, because this one is going to be only for fundamental. This is also going to be for fundamental. Our Kp is also going to be for fundamental. What about H harmonic? In case of H harmonic, one simple thing you have to do. In place of epsilon, just put H epsilon. And in place of gamma, just put, means, let me just write it. For H harmonic, what to do is, just replace epsilon by H epsilon. And this one as, for here, just replace H as, what sir? H gamma. Right? See here, a small correction, see here. So, for H harmonic, replace epsilon by H epsilon. And for H harmonic here, in case of distribution factor, just replace gamma by H gamma. That's it. In this particular formula, just replace this, you will get the answer. Yes, everyone, see here. Very easy question. See. 3 phase, 50 Hertz, which means frequency is 50 Hertz, F is equal to 50. Let us write given data first. Given data, if you think of, frequency is 50 Hertz, right? Given. Then 8 pole machine, P is equal to 8. Okay. Then next, what is given? Important data, star connected. Then winding with 120 slots and 8 conductors per slot. Which means what, see here, winding having slots 120, so number of slots is equal to 120 slots. Slots is equal to 120. Then 8 conductors per slot. 8 conductors per slot. So conductors per slot is equal to 8. Right? And then they are saying flux per pole is 0.05 Weber. Flux in the average flux per pole. We already know that, right? This is going to be 5, which is equal to 0.05 Weber. Am I right? Now, what are we expected to find? So let us write to find. To find what, sir? Phase and line voltages. Phase and line voltages. So this is going to be EPH and EL. What is that we need to find? Now see here. Let me take it this way. Yes. See here now. We already know what is the frequency. We know number of poles. We know this, right? Now see here what we want actually see. What is the formula for EPH? Let us firstly write down the formula and then try to understand what are the things required in it, and then we will go with it. What are the things? See here. See here. We need EPH. EPH is equal to what, sir? Root 2 pi F phi NAC and what? Kp, Kd, right? Now see here. Let us try to find out the values. We have frequency, yes, we have frequency. We have this one, flux per pole, yes, we have flux per pole. What we need to find? We need to find this NAC and Kp, Kd, right? We need to find NAC and Kp, Kd. That is what is required. Rest, everything is there. Already it is given. Now, let us think of Kp. Kp, if you think of, what is Kp, sir? Kp is going to be cos of epsilon by 2. Now you see here, is there anything talked about epsilon? Epsilon in the sense short pitching angle. Is it given anywhere in this question? No, which means epsilon is going to be 0. Why? Because it has not been given that it is short pitched. We don't know whether it maybe it is short pitched or it is full pitched. We don't know, but they have not mentioned it in the question. That is the reason we are going to consider short pitching angle as 0, and we will say that it is going to be full pitched coil because they have not mentioned anything about the short pitching angle. So just take it 0 simply. So if I replace, put epsilon equal to 0, what do you get here? Kp is equal to cos of 0 by 2, which is equal to cos 0, which is 1. So we have found out Kp equal to 1. Right? Now, this was number 1 thing. Then, number 2 thing, what we want, sir? Number 2 thing we want is Kd. Let us think of Kd. Kd is what, sir? Kd is going to be what? Sin q gamma by 2 upon q sin gamma by 2. Now, we was always thinking, firstly write down the equation, EPH equation, and then try to see what are the things we have to find, and then just go in that way, reverse way, right? Now see here, what do you require here? You need values of q and gamma. What is q then? Q we already know. What is q, sir? Q is going to be slots per pole per phase, right? So now see here, what are total number of slots? Total number of slots is 120, right? 120 divided by what are number of poles? Number of poles, P is 8. Let me write down 8. Divided by phase. How many phases it is given? 3 phase, right? 3 phase, right? So now you please tell me, slots is 120 degree, pole is 8, and how many phases are there? 3 phases it is given, so it is going to be divided by 3. What is going to be the answer? Therefore, Q is going to be what? So Q, if you think of, Q is going to be this one, 8 divided by this is going to be 15. See here, 8 ones are 8 ones are 40, 4 5 15. 15 divided by 3 again is going to be 5. So Q is going to be 5. Value of Q is known. Let us find gamma. What is gamma? Gamma is slot angle, right? Gamma is slot angle. If you think of gamma, gamma is what? See here, slot angle in the sense total number of slots, degrees. How much it is? P into 180. P into 180 divided by slots. What do we get here? So P into 180 is total electrical degrees, we know. Total electrical degrees, circle. Total electrical degrees is P into 180. Divided by that is slots. So what do we get here, sir? P is what? 8. 8 into 180 divided by slots. How many slots are there? 120. Right? So the answer is going to be 8 ones are 8 ones are 15s are 15 ones are, and this is going to be 12. So gamma, if you think of, gamma is going to be 12 degrees, right? By the way, if you already have that idea, this particular degrees is in electrical degrees. These are electrical angles. Now see here. Let us replace those values here and then try to find out the answer. What is that going to be, sir? It is going to be sine. What is Q gamma by 2? Q is going to be 5 into gamma. Gamma is what, sir? 12 degrees. Electrical, whatever it is, forget about it. Divided by 2. Then next what you need? Q is what? 5 into sine gamma by 2. Gamma is going to be 12 degrees by 6. If you solve this, the answer here is going to be 0.9565. This is our KD. Now, what do we need, sir? KP is known now, KD is known now. We need NAC. NAC means number of series turns. Forget about it. See here. Series in the sense, don't think much about it. Number of turns you want, right? Now you please tell me, what is given there? There are 120 slots. There are 120 slots. And in one slot, conductor per slot is given as 8. Means there are 120 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 120 slots. 120 slots. Within each slot, there are 8 conductors. So you please tell me how many will be the total conductors. Number of slots multiplied by conductor in each slot, right? So it is going to be what, sir? Total conductors, if you think of. Total conductors. This is third one, let us say. Total conductors is what, sir? Total conductors is going to be, what do you say? Total conductors is going to be number of slots multiplied by conductor per slot. Conductor per slot. It is going to be 8. Right? Total there are 120 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 120. Total 120 slots are there. And in each slot you have 8 conductors. So now you please tell me how many will be the total conductors. It is going to be 120 into 8, which is equal to, it is going to be 960 if you calculate this. Now you please tell me, these are total conductors, but you are speaking about a 3-phase machine. 3-phase machine in the sense, if there are total 960 conductors, right? So how many conductors will be available for single phase? In the sense, these 960 conductors are of complete 3-phase, right? Complete 3-phase. So how many conductors will be there per phase? Per phase is going to be, since these are total number of conductors, per phase conductors per phase. It is going to be how much, sir? 960 divided by 3, which is equal to 320. Right? Now, these are conductors per phase. But are we interested in this one? No. We want number of series turns. Number of turns, right? So, how to find those? Number of turns will be what? We already know that. See here. If you have 2 conductors like this. If you have 2 conductors like this, then what is going to happen? This is going to be back-to-back connected this way. Already we have seen. Which means for 2 conductors you have 1 turn. Right? For 2 conductors you are going to have 1 turn. So for 320 conductors, if there are 320 conductors like this, then you will have how many turns? 320 divided by 2, because we have already seen that 1 turn is equal to 2 conductors. 1 turn is equal to 2 conductors. So it is going to be, see here, conductor per phase is gone. Now let us think of number of turns. Number of turns is going to be, see here, number of turns is going to be 320 conductors per phase, or you can say number of turns per phase is equal to what? Conductor per phase divided by 2, which is equal to 320 by 2, which is equal to 160. So there are total 160 number of turns. So this 160 is going to be what? Number of series turns. Number of series turns is going to be 160 degrees. 160 turns, right? This is going to be 160 turns. Now see here. What do we have next? We just need to replace the values. That's it. Now, because we have got this NAC, we have got KP, we have got KD. Now let us replace those values and then we will find out. By the way, you may ask me, sir, but why you are so much interested in per phase conductors? Because our formula is for per phase. We are thinking about per phase only, EPH. So everything that you have should be with respect to per phase only. That is the reason I am here considering conductor per phase, number of turns per phase, and it is equal to 160. Anyway, see here. Now EPH, just simply substitute the values and we'll get the answer. See here, it is going to be EPH. EPH is what, sir? EPH is going to be, what do we have here? Root 2 pi. So this is root 2 pi, right? You have F. What is F, sir? F is 50. Then what is next? Phi. What is plus phi? Average flux per pole. It is given as 0.05 Weber multiplied by, now what is next? NSE. What is NSE, sir? Number of series turns, 160. So this is going to be 160. Multiply by what is next? KP and KD. If you think of KP, KP is 1, KD is this one. So it is going to be 1 multiplied by KD is how much? 0.9565. So it is 0.9565. What is it equal to, sir? The answer that you get here after calculating is 1699 volts. This is going to be EPH. This is what you need, right? You wanted phase voltage. But now, what about this one? What about line voltage? If you think of line voltage is what, sir? Because they are talking about what? Star connection. For star connection, if you see, where can I write? Let me write it here. See here, see, very easy. If you think of star connected, this is star connected, right? This is star connected. So in star connected, if you see, this is for example E line to line, or you can say face to face voltage also, and this is phase voltage, right? EPH, or we can say E line also. There is no problem. Line voltage and phase voltage. So in star, if you see, what is there? They are definitely not same, right? Because this EPH is between these 2 points and this EL is between these 2 points. This extra thing is there. So from the from your first year, or something like that, first year or second year probably, you must have studied that EPH is going to be EL by root 3. Am I right or wrong? For star, phase voltage is going to be line voltage by root 3, EL by root 3, or EL by root 3 if you think of. So what will be EL now, sir? EL will be root 3 into E phase. Root 3 will go there. So EL will be equal to root 3 into EPH. Let me just replace it. EL is equal to root 3 into EPH. What is EPH, sir? EPH is this one, 1699 volts. So therefore EL is going to be, the answer that you get after calculation is 2942.8. 2942.8 volts. So this is the answer. This is EPH, phase voltage, and this is the line voltage which you have got. So basically, see, always remember this thing. What you want, you know this equation, right? If you know this equation, just firstly analyze this equation. Try to find what are the unknown values here, and then try to attack them separately. Separately attack KP, separately attack KD, separately attack values, and then you will understand that stuff. It is going to be very easy. Yes. Now, next question, if you think of it. Let us think of next question. Yes. So now let us think of second question. Question 2. Yes. Yes, everyone. See here. What is given? What is the given data here? Given data, if you think of, it is what? 3 phase, 16 pole. So P is equal to 16. The next generator has resultant air gap of 0.06 Weber per pole. So it is going to be Weber per pole. Flux phi, average flux per pole is going to be 0.06 Weber. Right? Now next, the flux is distributed sinusoidally. Yes, we already know that it is sinusoidal only, because we have already studied that KP and all, KD, KP and all, those are always, what do you think, what do you say, are actually formulated for N1 S1, right? So it is going to be always sinusoidally distributed only. Anyway, see here. So this is going to be flux phi. Then the flux is distributed sinusoidally over the pole. The stator has 2 conductors per slot per pole per phase. Means slots per pole per phase is nothing but Q, right? Slots per pole per phase. It is going to be how much, sir? 2. Right? Now see here. And conductor per slot is how much? Conductors per slot 4. The next is what given? Yes, see here. So we are having 2 layers, right? 2 layer winding given. 2 layer means what? See here. For example, this is one slot, right? So this will be divided into 2 layers this way. And then here conductors will be placed, whatever they are. Anyways, but then if you think of what is given, 4 conductors per slot, 4 conductors per slot in, which means one slot will be having 2 layers, and in each layer I will be having 2 conductors. Anyways, don't just ignore this one. We don't need it. Anyway, see here. What is next? The coil span is 150 degrees electrical. Coil span in the sense, you will see. Electrical. Then what is next? Calculate the phase and line voltages. So to find EPH and E line, this is what is expected. Now see here. See here. Very easy. Just think of solution. What is the formula for phase voltage? EPH is going to be what? Root 2 pi F phi NSE Kp Kd. Right? Now see here. If you think of flux is given, yes, flux is given. Then what else is given? Nothing else is given. Now see here. Very simple. Means we need to find this frequency. Then we need to find NSE, Kp and Kd. Let us try to find it. It is going to be very simple. For frequency, if you see, for frequency, they have not given frequency, but they have given something else. What is that? See here. They have given machine runs at 375 RPM. Means N is equal to 375 RPM. Now see here. We already know that N is equal to 120 F upon P. So F will be N into P by 120. So if you think of frequency from there, if you try to calculate frequency from there, F is equal to Pn by 120. Right? This is space to time if you think of, right? Remember that. Now this is Pn by 120. What is P given here? P is 16 multiplied by, what is N? Speed is 375 RPM divided by 120. What is the answer you get here? What is the answer? See, answer that you get here, frequency is going to be, if you solve this, you get 50 H. This is going to be 50 Hertz. So F is known now. F we have known. Already we know flux. Let us try to find NSE. What is NSE, sir? Very simple. See, if you think of NSE, see, NSE. If you see here, they are saying that there are 4 conductors per slot. Right? And number of slots is how much? Number of slots is not given. Right? Because there are 4 conductors in one slot, but total number of slots is not known. But for that, what have they given us? They have given us Q. In order to find that one. So see here, very simple. What is Q? Q is going to be slots per pole per phase. And it is given to be 2. Now, if you think of slots, this Q is 2, right? Let me write 2 here. These slots, number of slots we want, we need to find number of slots. This is S, right? Number of slots we want. What is poles given? Poles is 16. Divided by phase is going to be 3. So what do you do here? You just take these things here and just multiply them. So you get slots will be equal to what? 16 by 3 here. So there it will go 3 by 16. Right? See here. This is 16 by 3 here. So this 16 by 3, if you take there, for example, see, this way if you think of. This is 16. See, 2 equal to slots S by 16 by 3. So if this is S, this is nothing but S by 1, we can take it that way. So this is S by 1, then this goes here, this goes here. So what do you get here then? You get here that S into 3 divided by 16, right? So if you think of slots, you get slots equal to 16 into 2 by 3. So here it is going to be 16 upon 3. I hope you have understood this one. This is school level mathematics. So what do you get here then? You get slots equal to 2 into 16 is how much? 32. 16 is 32. 32 divided by 3. What do you get here? See here. Already they have given what? 4 conductors per slot. Meaning that if I somehow know total number of slots and I have 4 in single slot, which means total number can be found out. So basically if you think of, let me first find out number of slots. To find number of slots, see here, they have not given here, right? Number of slots is unknown, but they have given us Q. Q is equal to slots per pole per phase. Means, see here, slots per pole per phase, slots per pole per phase. So if you think of here, slots per pole per phase is given, which is 2. So 2 are here. How much will be there per pole? Multiply the number of poles. Number of poles is how much? This will be per pole, and then again total. Total if you want in the sense. What do you get here? Phase. Because it is slots per pole per phase is given, right? Slots per pole per phase. So if you want this one here, number of slots is going to be 2 times poles into pH, because Q into P into H you can think of. So here what do you get is, this is Q, right? 2 is Q. Anyways, 2 into number of poles. Number of poles is 16. Multiplied by phases is going to be 3. And it is equal to what? 2 into 16 is 32. 32 into 3 is 33 is 90, 93, 96. 96 slots. Total number of slots is going to be 96. Right? Now see here, we already know that there are 4 conductors per slot, which means total conductors is going to be how much? Total conductors is going to be how much? 4 in single slot and 96 slots are there, which means it is going to be 4 into 96. 4 into 96, if you calculate this, this is going to be 384. This is going to be 384 conductors. 384 conductors. Now, if you think of total number of conductors per phase also you need to find, right? So, if you think of total conductors per phase, then it is going to be how much? 384 divided by 3. So, it is because it is 3-phase machine divided by 3, which is equal to how much? 3 1s are 3, 3 2s are 6, 2 4, 3 8s are. So here you get 128 total conductors per phase. But now, are you interested in this one? No, you want number of series turns, right? Where it is one? Yes, you want this one, number of series turns. What will be number of series turns? Number of series turns will be nothing but total conductors per phase divided by, this is per phase, right? Divided by 2. Because I know that 1 turn will have 2 conductors. So if 128 are there, then number of turns will be nothing but 120 divided by 2. Now see here, what do you get here? This is 6, 4. So you get 64 number of turns. You get 64 number of turns. So basically NSE is also found out. Anyways, let us think of Kp and Kd. See here. For Kp, what is the formula for Kp? Kp is cos epsilon by 2. Right, Kp is going to be cos epsilon by 2. Epsilon is short pitching angle, but now here again they have not mentioned about short pitching angle. But if you think of in the previous one, there was nothing mentioned about it. Here also not mentioned about it. So it has to be how much? 0, right? No, it should not be 0. Why? Because they have given, where it is gone? They have given coil span. Coil span is given, right? Which means even if they have not mentioned about the short pitching angle, by using this coil span we can easily find it out. So see here, come here, see. This is coil, right? In case of full pitch, it is going to be 180 degrees electrical. Distance between them is going to be 180 degrees electrical in case of full pitched. Now, since they are saying that it is now 150, means now the distance is, coil span is 150. Now the coil span is 150. If it was full pitched, coil span would have been 180 degrees. But now, since it is short pitch, it is going to be 150 degrees. I know they have not at all mentioned here about short pitching, but by this angle 150 degrees, if it is there, it means that it is short pitched only. So this is coil span. Coil starts here, ends here with a lesser angle. So how much is epsilon? That is the question. Epsilon is going to be, epsilon if you think of, it is going to be this one. So how much is this angle? 180 degree total minus 150. So this is 180. Epsilon is equal to 180 minus 150, which is equal to 30 degrees. So here you get epsilon equal to 30 degrees. So, right? So now just replace it. What do we get here? Kp equal to cos of 30 degrees by 2, which is equal to, if you solve this, you get 0.9569 as Kp. So here if you think of, Kp is also known. Now let us think of Kd. Kd is on the left, right? So Kd is what, sir? Sin q gamma by 2 upon q sin gamma by 2, right? What is q, sir? Q is given, no problem. What about gamma? Gamma is nothing but what? Let us find gamma. Gamma is what? Slot angle. Slot angle in the sense total electrical degrees divided by number of slots. Total electrical degrees is how much? P into 180. So P cross 180 degrees divided by number of slots, which is equal to how much? P is how much? 16. 16 into 180 degrees divided by slots. What is number of slots? 16. Sorry, number of slots is how much? Yes, number of slots is 96. So this is 96. Right? If you think of 16 ones are 16, 6 are 96. 16 6 are 96. Then this is 6 ones are 30. 30 degrees. So you get gamma equal to 30. Right? So now just replace this gamma here, meaning that sin q. What is q, sir? What is q? Q is going to be, where is q? Yes, q is 2. 2 into what? Gamma. Gamma is 30 degrees. 30 degrees divided by 2 upon, what is q? Q is 2. 2 into sin gamma by 2. What is gamma, sir? 30 degrees. 30 degrees into 2. The answer that you get here is going to be Kd equal to, Kd is also going to be 0.9659. This is going to be Kd. Now see here, Kd is also known. What we need now? Phase voltage and line voltage. It is very simple. So yes, so now what is left to find? Yes, everything we have. What you need? EPH and E line. Very simple. How to find EPH? EPH is how much, sir? Root 2 pi f. Let us replace those values. Root 2 pi into f. What is f here? F is frequency. F is 50 Hz. F is 50 Hz. Multiplied by f is done. Then phi. What is phi given? Phi is given 0.06 Weber. 0.06 Weber per pole. Multiplied by, what do you need here? What is next? NSE. NSE is how much? Number of series turns. Yes, 64. NSE is 64. So this is going to be 64. Multiplied by 64. Multiplied by what? NSE is done. Kp. What is Kp here? Kp is going to be 0.9569. Multiplied by what? 9659. If you think of, the answer is going to be E phase is equal to, so it is going to be 795.33. By the way, if you think of here, there is a small mistake here. It is not 9569. If you actually calculate it, it can be ignored also, because approximately it is going to be same. Rather than 9569, it is going to be 9659. And it's okay, there is no such issue with it. Even if you take that much, approximately answer will be same. Anyways, we have found out EPH. Now, what about E-line? E-line is going to be, we have seen, but if you see here, they have not at all mentioned anything about it. If they have not mentioned, then it has to be compulsory in star. Not mentioned, then it is star connected only. Always remember. If they have not mentioned anything in the problem, then it is going to be star connected. So for star connected, we have seen here, we have seen that E line is equal to root 3 into E phase, which is equal to root 3 into, what is that, 795.33. Therefore, E line that you get is going to be, so E line is going to be this much, 1377.55 volts, and here this is also going to be 795.33 volts. This is all about the second problem. Now let us take third problem. Yes, so now let us think of third question. Yes, so now see here, what is the given data, sir? Let us find out the given data. Given data, what is given? 10 MVA, 1 kV and all. Let us don't think about it. This has to be 11 kV by the way. Yes. Now see here, given data. Given data is what, sir? 50. Frequency F is equal to 50 Hz they have given. Rated frequency they have given. Then what is next? 4 pole. Number of poles is 4. Right? 750 RPM and rated speed is given to be 750 RPM. Right? Now star connected. Alternator is driven at 300 RPM, means actual speed at which it is rotating is 300 RPM they have given. N is equal to 300 RPM. Now, armature winding is having 360 slots. Slots is going to be 360. With 6 conductors per slot. Conductors per slot is 6. 6 conductors per slot. The coil span is 5/6 of pole pitch. Coil span is equal to 5/6 of pole pitch. Then next, what is given? Calculate the flux per pole required, means to find flux per pole. In the sense, we need to find phi average in order to get 11 kV line voltage. In order to get 11 kV line voltage, you need to find how much flux is required. Let us see. Now see here, how to calculate, sir? See, we know E phase solution. See here, we know E phase. What is E phase, sir? Root 2 pi f phi NSE PNKD. Now, do you know E phase? See here, what are they saying? 11 kV line voltage. 11 kV line voltage in the sense, EL is there. Line voltage you know, but you don't know phase voltage. In the sense, you need to find phase voltage that can be found out very easy, right? Root 3 and all we can take. Then, next is root 2 pi, you know, F. Frequency is also given 50 Hz. But should we use this frequency or some other frequency? We will talk about it. Anyways, let us think of phi. What is phi here? Phi is going to be flux. This is what we need to find. Flux is to be found out, right? NSE, is it given? No. We need to find NSE also. We need to find KP also, KD also. And EPH is only known. So, let us see here. Let us think of EPH first. EPH will be what, sir? Phase voltage is equal to, because since they are saying that it is star connected, for star connected it is E line upon root 3. Now, line voltage they are saying 11 kV, so it is 11 kV divided by root 3. Root 3 is, what is that equal to? Let us see. If we just try to solve this, it will be 6350.85. Now, EPH is known, right? Now, we need to find frequency F. What will be the frequency? Because see here, rated frequency is 50 Hz, we know. Rated frequency is 50 Hz. But right now, the alternator is driven at 300 RPM. Right now, it is driven at 300 RPM. Which means, for this 300 RPM, we need to find the frequency. New frequency, if you think of. So, this will be that frequency for 300 RPM. So, what is frequency F, sir? It is going to be Pn by 120. So, P into N by 120. Right? N is known. But what about P, sir? P we don't know. So, for that, see here. We don't know P, right? So, how to... Yes, P is known. Already given. 4-pole machine. 4-pole machine is given in the sense this is going to be P. P is how much? 4 multiplied by N. N will be now 300. This 300 will be written here. Divided by 120. Which is equal to 10. So frequency here is going to be 10 Hz. If I am rotating it at 300 RPM, it is going to be 10 Hz. 10 Hz. Now, let us think of next. Frequency is calculated now. What is flux phi? We need to calculate. What is NAC here? NAC in the sense, number of series turns. For that, see here. What do we know? We know total number of slots as 360. And we know that conductor per slot is given. How much it is? 6. So, what will be total number of conductors? Total conductors is going to be 6 into number of slots, which is nothing but 6 into number of slots. What is number of slots? 360 degrees. 360 slots. So, it is going to be 360 into 6, which is nothing but, it is going to be 2160 conductors. Total conductors. Now, let us find total. They are total conductors, right? Now, let us find total conductors per phase. How much it is going to be? 2160 upon phase. Means 2160 divided by 3 phase. So it is going to be somewhere around 720. So total conductors per phase is 720. Now, we need to find number of turns. Number of turns is going to be NAC. Number of turns is how much? Total conductors per phase means 720 divided by 2. It is going to be 360. So we have got 360 turns. NAC is also known. Now, let us think of Kp. For Kp, if you see here, Kp if you see, Kp is going to be cos epsilon by 2. Epsilon is not given, but they have given us coil span is 5/6 of the pole pitch. What do you mean by this 5/6 of pole pitch? 5/6 of pole pitch means, see, what is pole pitch first? How much will be the pole pitch? If it is full pitched, then we know that, see, if this is the conductor, there are two conductors, let us say A dash, and if it is full pitched, right, then for 2 pole we know that it is going to be 180 degrees this way. 180 degrees is the total. Full pitched, then it is going to be 180 degrees. Now, since they are saying that it is 5/6 of pole pitch is the coil span, means coil span is, so this one from here to here, if you see distance, it is going to be 5/6 of pole pitch. Pole pitch is 180 degrees, right? So pole pitch is 180. This is going to be 6 1 6 3 30. 35 150. So coil span is going to be 150. Now we have seen that if Coil span is 150. If this is 150 and this total is 180, then this one epsilon, this epsilon is going to be 180 minus 150, 30 degrees. Right? So it is going to be 30 degrees. So epsilon is going to be 30. So what is that? Cos of 30 divided by 2, which is equal to, therefore Kp is equal to 0.9659. So Kp is also known. Where is that? Yes, Kp. Kp is also known. Let us try to find Kd. What will be Kd, sir? Kd is going to be sin q gamma by 2 upon q sin gamma by 2. Already we know this. Yes. So if you think of here, what is q? Q is going to be slots per pole per phase. If you see here, what have they given us? They have given total number of slots. Slots is given, right? So see, to find q, q is going to be slots per pole per phase. So if you see here, total number of slots are 360 divided by number of poles. Number of poles is 4 divided by number of phases. Phases is also 3. So it is going to be 360 by 4 is how much? 4 over 90 by 3 again, 30 degrees. So this is going to be 30 slots per pole per phase. Or we can say that slots available for distribution. Anyways, this is going to be q, which is 30. So here just replace 30 in place of q. But now we need to find what? Gamma. Gamma is important. What is gamma, sir? Gamma is going to be, we know that gamma is slot angle, means total electrical degrees. Divided by what? Divided by slots. So total electrical degrees is P into 180 divided by number of slots. What is number of slots here, sir? Number of slots is going to be, sir, 360 given. Or let me write here slots only. S. So how much it is? P is 4. 4 cross 180 divided by 360. Right? 4 ones are 4 nines are 90. 90 ones are 92s are. So gamma is equal to, this is going to be 90 only, right? 4 ones are 4 nines are 36, 90. Gamma is going to be 2 degrees. So if you see here, gamma is equal to 2 degrees. Now you have value of q, you have value of gamma. You just replace it here. What do you get then? Therefore, sir, Kd, if you think of, Kd is equal to what, sir? Kd is equal to sin q gamma. Sin q. What is q? 30 into gamma. Gamma is 2 degrees divided by, what do you say? 2 upon q sin gamma by 2. What is q here? Q is going to be 30 into sin gamma. What is gamma? 2 degrees by 2. By the way, if you see here, if you observe this angle here, it is in degrees. Is it okay to write here? Yes, there is no problem. We are supposed to take angle only in radians in case of phase spread. Getting my point, right? In case of phase spread, because for phase spread we know that it is going to be, what do you say, sin sigma by 2 upon sigma by 2. That is where we need to take it. But right now there is no need because phase spread is not given. So let me just not think about it. It's okay. Here only we need to take in radians. Otherwise degrees also can be taken for this one when you think of q gamma by 2. So now if you see here, what is that? This answer, if you think of this answer that you get is going to be, 2 gets cancelled. This is sin 30. 2 gets cancelled. This is sin 1 30. Somewhere around half by 30. Let us see what is the answer. This is going to be Kd 0.9549. So you have also got Kd. Everything is there. You just need to find value of phi. So how is going to be the phi, sir? Phi is going to be very simple. See, this phi. If you think of phi, if you keep this on RHS itself, just shift everything there. Here it is in multiplication. There it will go in division. So it is going to be EPH divided by root 2 pi f NAC Kp Kd. So it is going to be EPH is in LHS. Let it be there. EPH divided by what, sir? divided by root 2 pi multiplied by, what do you say, frequency. Frequency is what, sir? Let me just write the formula first. Frequency multiplied by NAC Kp Kd. Right? We know all the values now. Let us replace them. EPH is going to be how much, sir? EPH is, you have seen, it is going to be 6350.85. So it is going to be 6350.85 divided by, see here, root 2 pi. Root 2 is where, sir? So root 2 is going to be, root 2 pi is same. Root 2 into pi into, what is f? F is going to be 10h. F is 10h we have got. So this is going to be 10 multiplied by NAC. What is NAC, sir? NAC is here, 360 tons. This is going to be 360 tons. Multiplied by, what is Kp? Kp is going to be 0.9659. 0.9659 multiplied by, what is that? Kd. 0.9549. Let us find value of phi. Therefore, phi is going to be how much? Let me solve it. So here flux is going to be 0.43 Weber. This is the answer. Now let us think of fourth problem. Next problem.